everybody, this is Jason from the Children's Museum of Houston, here again to talk a little bit about geology. Last time, or if you're watching the first video, which was about geologic forces, the volcano, the erosion slide, stream table, and how to make a metamorphic rock, that was, ways in which the geologic forces of the Earth create different types of rocks. Igneous with the volcano, sedimentary with the erosion, metamorphic with the intensity and pressure. Now we're going to have a chance to look at these different rocks that are formed in a much closer manner. For this activity, you really want your students to be using their journals. They want to get down as much information as they can about each rock and each mineral. The reason why they want to do that is when they write in their journal about these different rocks and minerals, they are actually becoming geologists. This is exactly what geologists do. They go out into the field. Field work is when you're not inside a laboratory. They go out into the field. They look at different rocks. They sketch the rock into a notebook. They write a few things about the rock. They write what's around the rock, other rocks or other minerals that are around it. And then they take it back to their lab, the rock as well sometimes, and they study it even closer with electron microscopes and whatnot, and computers to see like the inner structures, to see what kind of crystalline shape they might have, to see what kind of geometric shapes they might have, things like that. So it's really important that when your students are working on this activity, that they're picking a mineral out, setting it down. First thing they need to do is draw it. You always want to draw it. And then just write a few observations down. So take this pyrite, for example. This is a mineral, okay? They would take this pyrite, they would have their journal open, and they would draw the pyrite, the shape of the pyrite. You have crayons and markers and whatnot. Go ahead and give it to them. They can put the yellowish color in or the goldish color in. They can talk about the crystals. They can talk about if it was layered or not. They can talk about how they think it was made. They can talk about, does it feel heavy in their hand in comparison to other minerals and rocks of a similar size. Right? All these different kinds of things now. Then they can perform tests on the minerals and rocks. So when they're performing these tests, they were designed to simply just show that rocks do certain things. Are they magnetic? Do they make a streak? Can they be scratched with your fingernail, or does a nail have to be involved? A steel nail have to be involved, okay? So they start to think about these things, and that helps people, scientists, geologists, classify these rocks further besides just being igneous or metamorphic or sedimentary. So first thing they have to do is determine the difference between a mineral and a rock, and that's pretty simple to do. Pyrite's a mineral. Minerals are a little bit easier to understand than rocks in this sense. Minerals are inorganic, which means they are not living things. They are inorganic. They might have living things around them, like mosses and lichens and whatnot, but the actual structure itself is an inorganic, non-living substance. They have to be solid. Rocks or minerals cannot be liquid. They cannot be gaseous. They have to be solid. See how you can tie in different things here? Like if you've already done your chemistry unit, you can tie in the states of matter again, which is this state of matter, solid, always. And they have to have a definite internal crystalline and geometric structure. All right, so all of them have different geometric crystalline structures, which is very hard for us to determine when we just look at a mineral like pyrite, because we don't have the equipment, the electron microscope and the computers and whatnot to reconstruct that. But it's something good for them to know. Rocks, on the other hand, are just a collection of minerals. So different minerals make up a rock. So if pyrite and calcite and mica all combine together, it's a rock. It's no longer a mineral because it's more than one. If you only find pyrite, it's a mineral because like an element, there's nothing else in it but pyrite. Hydrogen only has hydrogen. Pyrite only has pyrite. So once you determine that, you can perform your test. So typically, there's a couple different tests you can perform. First, always use a magnifying glass. Take a closer look at it. See what you can see. Write down the things you can see. Because when you take a magnifying glass, you can sort of see a little bit more of the crystalline structure. You can sort of see how the rock got formed together or the mineral got formed together, things like that. Next thing you want to do is take this porcelain streak plate and see if it makes a streak. Look, this goldish color mineral made a grayish black streak across this porcelain streak plate. Go ahead and write that down. That's what you want your kids to write down. You say like, hey, it's gold, but it made this kind of streak. Then see if you can break off any of it with your finger. Now, pyrite is pretty hard to break off with your finger, but you might be able to do it on the edges. So what you're probably going to have to use is the steel nail and see if you can scratch it, break it off, do things like that. All right? Make sure they're being careful with it. You don't want to like get your, because you got to keep it sharpened. You don't want them to like stab their fingers or anything like that. So make sure they're being careful. Okay? That's another thing. When you try to determine the hardness of a rock by either being able to break it off with your finger or a penny or a piece of glass or a steel file like a nail, that's called the Mohs test. There was a geologist named Mohs. He came up with this test to determine the hardness of different rocks. So obviously the softest rocks can be taken off with your finger, nail. The hardest rocks have to use a steel file. So you do that test, and then you go ahead and take a magnet and you see if it's magnetized. Will the magnet fall off? Pyrite, it's not magnetized. All right? There is a rock here that is magnetized though, and it's oddly enough, it's called magnetite. This is magnetite. You can see that the magnet is sticking to it. So magnetite is one of the very few minerals that is magnetic. All right, so what you want to do is you want to put your students into groups of 4 and pass out a few minerals to them and have them test 2, 3 minerals at a time. Then you can give them more, so they can test every single one of these minerals. Remember how I said there's a hardness test that you can break off with your finger? Well, this is mica. See how you can break it off with your finger? It's not a very hard mineral, okay? Then you have extremely hard minerals like your pyrite and your magnetite, and your calcite, things like that. So have them perform all the tests, and then they can determine what each mineral is. Now, we're not asking them to like do a test to see like, oh my gosh, this one's this one and this one's this one. You have a guide. Once they're done determining what each rock might be, they can come up, and since they're numbered, they can go ahead, see that says number 8 for magnetite, they can go ahead and see. They can go, okay, I had a color that was black, it felt metallic, it's luster, how it feels. The streak was black. Look, I didn't streak magnetite, but if I go ahead and do it, you can see it's a blackish gray. And then you can sort of look at the hardness. Don't worry about the hardness number because we're not really giving you the Mohs scale. But then one of the properties is it's magnetic. So they know that number 8 is magnetite. So once they've done all the tests, they can come up to the sheet of paper that you can hold for them, and you can be like, okay, which one do you think this is? And they can write it down next to the mineral. Rocks, then you can do the test the same way. You can look at it, and what's really cool is you can look at, say, this gneiss right here, and look at these minerals and say, I wonder if this pinkish feldspar is part of this gneiss. I wonder if this calcite or this other type here or this type here or whatever type it is part of this rock. So you can start to determine which minerals are in which rocks, and they can also write about the rocks themselves. So even though it seems like there's not much going on here, there's a lot going on here. This is exactly, like I said, what geologists do. More than any other activity they're going to do for this unit, this is the one that is actually making them become a real geologist. They could actually sit there, and if a geologist came in unexpectedly, like a parent, and saw them doing streak tests and Mohs testing and magnetic testing and looking at minerals through magnifying glasses, they're going to be like, wow, that's what I did when I was a college student. So they're going to be ahead of the game in certain things, and they're going to be able to start to think critically more about how to collate and how to write down different minerals and different rocks. Okay, so have a good time with this one, and this is Jason signing off, and we got a couple more videos coming up. Go ahead and watch those too, and you'll be good with your geology unit. Thanks a lot, guys. Bye.